very good day to Dr. Zafran. So we are from Group 9 and we are from Group Top Global. So now we are going to present about our OS project, which is free space management. So as I mentioned, we are doing free space management. And this group consists of 4 members, which is Amirun Irfan, me, myself, Wilson, and Hafiz and Ravinesh. So now I'm going to explain what is free space management. So basically, free space management is an operating system that track which disk blocks are available and which are currently in use. So to demonstrate this concept, we are going to use parking lot as a real world analogy. So the blue cars are basically a block that already filled with data, and we call these blocks as allocated blocks, while the empty blocks represent free blocks that are available to be assigned when new data arrive. So just like a parking system, it needs to keep track of available and free space. An operating system must efficiently manage free and new storage blocks. So these concepts are known as free space management, and we will now show how different techniques are used to do it. So there are 3 different techniques that will be explained later on, which is bit vector methods, linked list method, and another method is grouping methods. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to Dr. Zafran. My name is Amirul Irfan and I'll be explaining on the bit vector method. So in this method, each storage block, or in our case, each parking slot is represented by a single bit in a bit array. So a bit value of 1 means the space is occupied, while a value of 0 indicates it is free and is available for use. So in our simulation, you can see a row of cars and some empty slots. Below them is the bit vector, which tracks the status of each slot in binary form. So if a car leaves its parking slot, the bit is reset back to 0, making that block available again. And when a new car arrives, the system begins scanning the bit vector from left to right, searching for the first bit that is set to 0. Once a free bit is found, the car parks in the corresponding slot and the bit in the vector is updated from 0 to 1, indicating the space is now used. So this method is very fast for checking availability and performing allocation or deallocation. However, for large storage devices, the bit vector can be a bit more intensive since each block must be tracked individually. That's all from me. Thank you very much.
Good evening, doctor. My name is Ravinesh, and today I would like to present about linked list method. Linked list method is another common approach to free space management in operating systems. In this method, instead of using a bit array, the system maintains a linked list of all free blocks. Think of each free parking slot as a node in a linked list. Each node holds a reference to the next free slot. The list starts with a node called the head, which always points to the first available space. When a new car arrives and need to be parked, it is assigned to the slot at the head of the list. Then, the head pointer is updated to point to the next available space in the list. If a car leaves and a slot becomes free again, it is inserted back at the head of the list, which is an efficient way to update the structure. One of the strengths of this method is that it is memory efficient since only free blocks are stored and tracked in the list. However, the drawback is that it can be slower for specific allocations, especially if you want to find a particular space, since the system might be need to traverse the list one node at a time. That's all from me. Thank you.
Alright, so Assalamualaikum. My name is Muhammad Hafiz, and I'm going to present about grouping method in free space management. Okay, so as you can see here, the first group, there are two group. Okay, the first group, group one include slot 2, the empty space, and also slot 3. Okay, because they are contiguous, which means they are side by side. And same goes to group 2. There is slot 5 and also slot 6, which is also next to each other. Okay, so for now the concept is the head pointer, it will point toward the first available free group. Okay, so which is group 1. Okay, so when a car arrive, it will needs two contiguous slot, which is slot 2 and also slot 3, the system quickly check on the group 1 and also assign both slot 2 and also slot 3. Okay, so you can see here. Alright, okay. So now the group 1 uh will remove from the list of the available group. Okay, so now the head is point toward group 2, which is the available slot is group slot 5 and also slot 6. Okay, so uh okay, the process is still goes on and on. So if there is car needed to empty slot, the head will check on the group 2 and will assign the slot 5 and so slot 6 to the car that needed. Okay, so this method is efficient because it keeps track of the group of free space instead of the linked list, which is every individual slot. Okay, so which this method will reduce the amount of information the system has to store and also the speed up allocation when large and also continuous space is needed. Okay. So I think that's all from me. All right. So thank you.